Welcome to your lesson on multiplying radical expressions. You just took a few moments to warm yourself up a little bit. I'm going to go ahead and show you some responses to those warm-ups. So let's do it. All right. Notice I did the problem two ways on number one. Method number one, if you go ahead and take a look at it, is I simplified the square root of 48, and then I simplified the square root of 12, and I observed that when I did that, the square root of 3's were stacked on top of each other, making a factor of 1 hang out in my rational expression. So I was then able to just reduce 4 over 2 and get 2. But let's keep in mind, we have this thing. Remember, I ask you every single time, you got to ask yourself, product, power, or quotient property. And in this case, I see a fraction bar, so that's the indicator that we're going to use the quotient property, right? Since I'm going to use the quotient property, I can actually glue those back together. 48 divided by 12 is 4, and then the square root of 4 is 2. You don't have to have both responses in your notes, but you should have one or the other. So either you did it the blue way, or you did it the red way. Whichever way you like the best is the one you should stick with. Both are correct. One uses the product rule as its justification. The other one uses our famous quotient rule as its justification. Okay. Questions on number one? Nice job. They look good as I was like eyeballing what you were doing there. All right. Next thing to get out of the way would be number two. You do have to simplify before you try to combine. So when we look at this one here, you do get 2 square roots of 5 as your final answer. Remember that when the most common mistake I'll see, maybe you're this kid, see this 2 that's out in front, students will forget to bring it down to be part of their response. So just a little heads up, make sure that 2 is in there so that you have 6 root 5 as the simplification for 2 root 45. So yeah, your answer there is 2 root 5. All right. Questions, comments, concerns on that one? All right, warm up number last. I used the quotient rule, and I went ahead and I just did 24 divided by 3. That's 8. And then you do have to leave your answers in simplified radical form, so I had to break 8 down into the square root of 4 times the square root of 2. So your answer there is 2 root 2. Any questions about that?
Wait.
What's up? What you got for me?
I just want to look at number 2 a little longer.
Oh, okay. How did you do it?
I didn't.
Oh.
I skipped it.
Why?
Valid.
I like the other 2.
Oh, you like the other 2 better? That was the one you voted off the island?
Yeah.
Yeah.
All right.
So I'm thinking you're not liking the plus and minus sign so much.
No.
It's because it's like 3 problems in one, huh?
I just don't understand how to do it.
How to simplify it? Did you understand how the square root of 8 on number 3 turned into 2 root 2?
Yeah.
Yeah? So that's all we did here. We had to identify the perfect square that goes into 45, and it was 9 times 5. Because 9 is a perfect square.
What'd you do with the 9 and the 5?
So we then take a minute to square root each piece. And then you know what the square root of 9 is?
3.
So that's that right there. And then the square root of 5 came down. So did this 2. 2 times 3 is 6. And then the square root of 5 you can't multiply. That's the first part. And then the same thing here. We broke this down into 16 times 5. So we square root 16 and you square root 5. So that's where 4 comes from.
Okay.
Now how do you feel about it? It's aight. Aight. All right, today, my friends, we review, to a certain extent, multiplying radical expressions. Again, this lesson is chunked out into 2 days. We do it with numbers. Then, I guess on Wednesday, we'll go ahead, swing in and do this a little bit with letters. But let's go ahead and take a look at that example 1. We know that we're going to work on multiplying radicals, and we kind of did one like this the other day. we have the square root of 3 touching that set of parentheses. What I need to remind you about in this chapter is that when there is no symbol between two things, the implied operation, you got it, is multiplication. I have students that will like randomly throw plus signs in where a plus line never was. We don't assume addition ever. We only assume multiplication. That is the only operation actually we ever, it's our implied operator. We just skip writing the symbol, right? So what I have to remind you about is that if this section messes with you, go ahead and put your dots in so that you're remembering when to multiply versus when to add or subtract. So a little heads up on that. So that square root of 3 is being multiplied by the quantity of 4 root 2 minus root 12. So I'm going to let the distributive property be my guide there. And I'm going to take the square root of 3 and multiply it by 4 times the square root of 2. Do you see I popped that dot in there? Again, there wasn't a dot, but if you need the dot to remind you it's multiplication, just go ahead and put it there. And then I'll bring down my minus sign that's in the original problem. And then I have to take that square root of 3 and multiply it by the square root of 12. And since I have all these products, the next thing I'm going to do is use my product property, right? So let's take a look at this expression here in red. 2 of the 3 things I am allowed to multiply together. What you got for me, Jesse? Oh, go for it. You could. It's going to be 6 one way, half a dozen the other. Like, you're still going to do the same number of steps. But if that were like if this square root of 12 here, Jesse, were like the square root of 4, I would definitely just turn that into a 2. Yeah. Do you know, though, in red, like what things I would multiply together? Yeah. We would use the product property that only applied to just the square roots. Well said, actually. This square root of 3 and the square root of 2, remember you can rearrange the multiplication too. So I'll show you what's happening in my head. I can't really multiply the 4, but I can multiply the square root of 3 times the square root of 2. And I can glue those things together courtesy of my product rule. So what I'm staring at in red there, the 4 comes down, but the square root of 3 times the square root of 2 is the same as the square root of 3 times 2. 3 times 2 is 6. And then I'll bring down my minus. And then the square root of 3 times the square root of 12. What would that be? Square root of 36, right? Oh, that's nice. That's a perfect square. Square root of 36, that's just 6. Can I subtract these things?
No.
Oh, I heard a no. What do you think, Royce?
You can subtract the 4 from the 6. The 6 and the 4. I think.
Do they have the exact same radical part?
No, they don't.
Right. If this had, so the answer to the question is no, you cannot subtract these. Royce, so what would have to be true? Let's address that for just a second. What would have to be true about this 6 in order to be able to subtract these things?
It would have to have a square root of 6.
Yes, this would have to have a square root of 6 attached to it, yeah. Is that what you were going to say?
No, you should erase it to that answer. You're like, ooh, I heard a no. That sounded, you made it sound like that was the wrong answer. I was like, whoa.
I mean, I like to make y'all think, keep you on your toes a little bit. But yeah, there's no, why I'm drawing this little wand here, is there's no square root of 6 attached to the 6. So they're not like terms. And maybe, you know, this might help Royce too, or maybe you're like, I don't know when to combine them. Like the square root of 6, I don't know what it is. It behaves like x. You would never put 4x minus 6 together in your pre-algebra class. So you can't put 4 root 6 together with the 6 now. So hopefully that helps. That's our answer. Done. Ta-da. Yay, 1 problem down. 3 more to go, and then I'll get out of your hair. What's up, Jaden? Yeah. Okay, see this guy here? This is FOIL. It's a binomial times a binomial. Jaden, you mind shutting the door too, bud? Thank you, sir. All right, so we are going to do firsts, outers, inners, lasts. Baby steps, people. Baby steps. Okay, firsts stand for the first things you see in each quantity. So what do I see? I see the square root of 5 times the square root of 5. I can use the product property on those because they're both housed in a radical with the same index. The square root of 5 times the square root of 5 is the square root of 5 times 5, which is the square root of 25. And then I'm like, ooh, square root of 25, that's a 5-er. That's done. O stands for outers, your outermost pieces of the problem. Again, FOIL is just a fancy version of the distributive property. I'm basically distributing each thing to each thing, each term to each term. Ish. So I'm going to go ahead now and take the square root of 5 times 2. But we don't have a product rule for something that's outside the radical and something that's inside the radical. We only have it for when both things are in a house. You can't let this guy move in here. Doesn't have the right clothing on or something. Yeah, so you just kind of write it as 2 times the square root of 5. Inners are always your innermost pieces of the problem. I usually do bring the signs along for the ride. So I'm going to have a negative 5 times the square root of 5. And again, we don't have a product rule unless things are both in a house. You can't put something outside of a house in with something in the house. We don't have that rule. It does not exist. So this is negative 5 root 5. And then my lasts are going to be the last pieces of your problem are just the last pieces in the parentheses. So that'll be negative 5 times positive 2. And the product of that is negative 10. Now, distributing always involves 2 things, right? Multiplication and then combining like terms or adding at the end. So the last step in FOIL is to do F plus O plus I plus L. So I'm going to do 5 plus 2 root 5 minus 5 root 5. Oops, that's supposed to be blue. Sorry. Minus 5 root 5 minus 10. And this is the spot where you need to combine your like terms. So I see 2 pairs of like terms. I don't know if you do. Can anybody give me one? What are 2 things we're allowed to combine in that line at the bottom? Professor Tashner.
The 2 root 5 and the...
Yeah.
5 root 5.
Oh, you went for the hard one first. Good job. So what is 2 root 5 minus 5 root 5?
Negative 3 root 5.
Nice. Legit, yo. All right. Sorry, I was enjoying my coloring. Okay, so negative 3 root 5. Ah. I know. Thank you. All right, 2 more things you can put together. Yeah. Yes. So Olivia sees these guys right here. Oh, thank you, Emma. So 5 minus 10, negative 5. Oh, I keep grabbing the highlighter. Negative. Come on. Yeah, that's it. That's what we're learning today. Distribute and FOIL. If you break a problem down into smaller pieces, it really does get to be more manageable. I promise you. All right, before I do another one, questions about this one? All right, you're killing it. Nicely done. On to part C. So you see we have 2 binomials multiplied together. Yes, sir? You want to help me with it?
Who wants to do this one?
Yeah, I want to do this
You want to do this one.
So
Talk me through some stuff.
the square root of 2 multiplies to the other, on the other side of the square root of 2, which gets the square root of 4. Square root of 2 and square root of 3 gets
Hold up. What's the square root of 4?
2.
Yes.
Are you simplifying immediately?
I do.
Oh, I understand.
Yeah, so I just like finish up that multiplication, take care of it. All right, talk to me about my outers now. So these pieces here.
So it'd be the square root of 2 and the square root of 3, which is the square root of 6.
Good.
And it'd be
Can I simplify the square root of 6?
you cannot.
Good job.
Um,
Then we got our inners.
negative square root of 3 and square root of 2, which is negative 6, which cancels out.
Ooh, I'm not there yet. Just leave it.
Huh?
We're going to write it as negative root 6. Good job.
Okay. And,
You're right.
And negative 3 square root, or the square root, negative square root of 3 and square root of 3, which is negative 9.
Good job.
Negative square root.
The negative square root of 9, which is
Negative 3.
-3. Very good. All right, and then, yeah, you kind of heard Jaden referencing it a little bit. We do have to do the adding part of our distributive property where we have to do f plus o plus I plus L. So you can bring that down. We got 2 plus the square root of 6 minus the square root of 6 minus 3. And then we got to identify the things that are like and the things that are not. So what are my like terms? What can I put together? Jaden, you said the first one. What am I allowed to like? You said cancel out, I think is what you said?
You can cancel out positive and negatives.
Yeah, these are like terms. So positive root 6 and negative root 6, they're going to go away. They're additive inverses of each other. So those are goners. And then what I have left over is a 2 and a negative 3. So we can put those together too. 2 minus 3. How about that? So if I do 2 minus 3, that's just negative 1. So all of this multiplied together actually gives us negative 1. Crazy. Actually equals a number. So we have an irrational times an irrational, giving us a rational number. It's pretty neat. Alrighty. Questions about that one? Because we got one left. You're gonna make it. All right. Part D is a FOIL problem in disguise. It's one of the more common mistakes I usually see in an algebra class. Y'all get, especially because we've done properties of exponents so often, you just get distributive happy with your exponents. But you can't distribute a square into a set of parentheses like that. That's a no-no. I encourage students, when you see a set of parentheses squared, you know, that's how the big kids write it, but to go backwards on that idea of the big kids writing it, this is the same idea as the square root of 5 plus 1 times the square root of 5 plus 1. So when you see these problems, you know, don't be shy. They're just FOIL problems in disguise. So I am going to FOIL. Anybody want to help me? Who haven't I talked to yesterday? Like, I don't know. Hey, Sadie, how you doing? You want to tell me about my firsts real quick? Thank you. Yeah. Square root of 5 times the square root of 5 is our first. Yeah, because it ends up being the square root of 25, and that's 5. Good job. Thank you for keep going. If you want to call in somebody else, we'll do it that way. Good. Yeah, 1 times 1 is 1. And then I just have to add. So I got to do my F plus my O plus my I plus my L. So F was 5. O was the square root of 5. I was also the square root of 5. Oops, it's supposed to be blue though. Sorry. And then plus 1. Hey Alex, how you doing? You wanna wrap this up for me? Put a bow on it?
Yeah.
What do we got?
6.
Good?
Plus root 10.
Nice idea. You use the product property. You're not allowed to like put those things together. It's like saying x plus x is x squared. That is not how that goes.
10. Root 25.
So it's, do you remember when we did like 3 square roots of 2 plus 2 square roots of 2?
When did we do that? Like yesterday? 2 days ago?
Or like, I don't know, the homework you did last night or the night before?
No, I forgot to do that.
Okay, so it's just combining like terms. What if I said to you 3x plus 2x?
5.
Yeah. Okay, what if I said 3z plus 2z?
5.
5z. Okay, so if I said 3 square roots of 2 plus 2 square roots of 2, you'd tell me,
5.
nice job. Okay, but it's not the square root of 2 this time. We have 1 square root of 5 plus another 1 square root of 5.
10 square root of
So we have, let me put the 1's in. 1 square root of 5 plus another one. So if you have 1x plus 1x, what's that?
2.
Yeah. And I don't know what the square root of 5 is. It behaves like an x. So if you have 1 square root of 5 plus another square root of 5,
2 square root.
yes! Way to muscle through it. That is combining like radicals. So you get 2 square roots of 5 out of that. Make sense? Alrighty there, my people. You got a little bit of independent practice to go ahead and take care of. And then you got some answers. Talk about that some more tomorrow.
What were you
And that
planning on
concludes
going
day
on?
1 of multiplying.